Push that rock with Simpson math. Let's factor by grouping. So we have a polynomial here, and we want to factor it. And to use grouping, we look for groups that have common factors. So this group has a common factor of x, so I'll factor out x. X times w is xw, x times negative z is negative xc, so did that. Now I'm going to factor out, this sign always comes down. You could treat it as plus or minus, but I just bring the sign down there, which means I'm factoring out a negative. And I look for a common factor, and it's y. And so I say y goes into that w times, and y goes into that z times. But wait a minute, I'm factoring out a negative. A negative y times w is a negative yw. A negative y times z would be a negative yz, so this must be a minus here. A negative y times a negative z would give me a plus yz. Now I see a common factor again. So just like on either side of this minus, I had a common factor of x, so I factored out an x. On either side of this minus, I have a common factor of a binomial. I know that's different, but it's the same concept. So on either side of the minus, I have a common factor of w minus z, so I factor it out. When I divide this into that term, let's kind of do it over here. Hopefully you can still see that on camera. So when I do it over here, I have x times w minus z, and I'm factoring out a w minus z, which means I'm dividing. Well then, that reduces, and I'm left with just x. So I have just an x here. And the same thing goes over here. When I divide this into that, I'm left with just a y. And this is the factorization of that polynomial there. Check. Now, whenever you factor, you should check it. So let's check it. W times x is wx. W times a negative y is a negative yw. Negative z times x is a negative zx. And a negative times a negative is going to give me a positive, and z times y is zy. Does this look like that? Well, yes it does if we're allowed to change order. See, we have wx. Is that the same thing as xw? Yes, it is. Then, can I put this second and this third? Well, of course I can. So I can make this minus xz, putting the x first, and then I can make that minus yw. And then I can put the y in front of that, and have yz, and this is the original polynomial, so see, I checked my work. Let's think about where this is coming from. Factorization is the sort of like reverse of multiplication. So let's multiply and see what's happening. So I have a pair of binomials here, and I multiply. X squared times x gives me x cubed, and x squared times 9 gives me 9x squared. So notice the x squared was common to both of these terms. Now I'm going to multiply 2 times that, and I get 2x, and 2 times 9, which gives me 18. And notice the 2 was common to both those terms. So that's where it's coming from. I can take out the common factor, which was x squared here, and get the x plus 9. I can take out the common factor of 2 from this group. So that took out the x squared from that group, and now I'm going to take out the 2 from this group, and that gives me the x plus 9. And since this is common, it's one of my factors. And the other factor is what that common factor is being multiplied by each time. So that's how the factor by grouping works. One last example. So the way it works is you look for a common factor in groups. So I see a common factor of t in this group. So I'm going to take out a t, and that leaves me 2r and a 3v. Okay, this sign comes down, and I look for a common factor in the next group over. And I see s. So I'm going to take out that s, and that leaves me 2r plus 3v. So this factorization is working because I got the same common factor right here, this 2r plus 3v, 2r plus 3v. So I'll factor that out, 2r plus 3v, and I multiply it by the other factor, which this goes into that, t times, and this goes into that, s times. And so there is the factorization of the polynomial I started with. Math made simple at Simpson Math.